Hello everyone, and welcome to the Energy Institute's An Introduction to Human Performance webinar. My name is Famida, and I'm the Senior Training Officer here at the Energy Institute. I'll be here throughout the webinar. Should you have any questions, should you have any issues with joining or hearing, anything like that, just let me know in the chat box and I'll be monitoring that. I'll start by just introducing the Energy Institute. So we are a professional membership body for those who work within the sector and across, who have an interest in energy. A lot of work we do is to provide knowledge, skills, and good practice across the industry. We produce guidance documents, knowledge resources, events, and training opportunities for our members. So this webinar will introduce you to the human performance. It will introduce you to human performance and the human performance pathway course that we run. I'll introduce you to Michael and let him take over in a minute. I'll just run through a quick few house rules before we start. If you could all just please ensure that you stay muted throughout the webinar, and if you could keep your cameras off as well, that would be great. There will be a chance for you to ask any questions at the end. We'll run a Q&A session. If you do have any questions that you think you might forget, just pop it into the chat box and we'll also run through that at the end of the session. Just to let you know that the training session will be recorded, so if you miss anything, the recording will be available after. I think that's it from me. I will pass you over to Michael, who will be the presenter of today's webinar. Michael, over to you.
First, thank you very much for the introduction, Famida. As you said, I'm a human factors specialist, having spent over 30 years working in this area, and I will this morning be introduction to human performance, covering a number of key points. Firstly, why should we care about human performance? Why should we invest our time and effort into this area? I'll then move on to what is human performance? What do we mean by that? What are some of its key concepts and principles? What's the scope of human performance? Which leads on to the question of who manages human performance in the energy sector? What are the roles involved in managing human performance? Which leads into the question of what are some of the challenges in implementing human performance within companies, and how might these challenges be overcome? I'll then conclude, and I'll be handing over to Alex from the Institute to carry on after me. So why care about human performance? I think, in a way, sadly and unfortunately, there's been a history of major accidents in the energy sector and many other sectors, railways, aviation, nuclear, chemicals, a long list of major accidents where human error has been a contributory factor either to the causation of the accident or being unable to contain and mitigate that accident. And what you have in front of you is one example, explosion at BP's Texas City refinery back in 2005. A tragedy, 15 people died, 180 injured. You see there the picture of the devastating consequences of the explosion. Billions of dollars in compensation, repairs, lost profits, reputational damage. Further after, featured as a case study in talks such as this. I'm going to talk through what happened in the next slides and drawing out where human performance played a role in this accident, but most equally importantly, the key principle of human performance is that human error is not the cause of accidents. We try to identify the factors that contributed and led to that error. And the key point of human performance is trying to understand the factors that may influence human performance, foresee those factors, and try to optimize those factors and then support people to perform tasks successfully without error. Human performance is all about foreseeing, preempting failures, and supporting successful task performance, which the next slides will hopefully support. And I should mention the next slides are all snippets from the CSB's video of this accident, which I'd give it to. So what happened? Well, the refinery was starting up an ISOM unit, which I've circled here in red, to get a tower, which they would be filling with this liquid, which is a flammable liquid. Equally importantly, just to the top left, circled in blue, the refinery had erected 10 portable trailers to house some contractors who were doing work elsewhere in the refinery, unconnected to the startup of the ISOM unit. But importantly, no one had mentioned to them that the ISOM unit was being started up, potentially hazardous activity. There was no suggestion to relocate during the startup process, no awareness of this hazardous activity going on nearby. And there are hundreds of workers housed in the portable units. The startup commenced on the night shift, and you have to start filling the tower. The standard operating procedure said to fill it to 6.5 foot. There's a gauge at 9 foot, but they would fill higher than 6.5 foot. This was standard practice, contrary to the procedure. And the concern was that if the level went low, it would cause problems, inadequate flow to the furnaces if the flow varied. So they're concerned about underfilling. So because of that, they would fill more than 6 foot. What they were unaware of was they had actually filled it on this occasion to 13 feet. The gauge obviously stopped at 9 foot. They would not know that. A high level alarm did not activate as an alarm failure. A high level alarm did activate, which was acknowledged. The significance was not investigated. So they had overfilled at this point, and unaware that they had. Handed over from the night shift to the day shift at 6 o'clock in the morning. Unfortunately, the lead night operator left early, which obviously impacted the handover. And here you got a picture of the new day shift operator. This was his 30th consecutive day at work. Started to work at 6 a.m. in the morning, and the early start obviously would have had him sleep loss that morning. They had to get up about 4, 5 to start to work at 6. The 30 consecutive days of work, obvious fatigue issue. And what's the impact of fatigue? Poor decision making, slower decision making, forgetfulness, lapses of attention, unable to process information. And this was the operator given the task to carry on with the startup process. What was the handover? There was a handover, a brief verbal handover. There was a logbook. The logbook had one line in it. ISOM brought in some RAF to unit to pack RAF with. Did not explain the potential level. There are no instructions on routing product in or out. The level in the tower is not noted. So a very brief, inadequate handover. The day shift supervisor arrived late and was not briefed at all. So the day shift, unaware of the level, poor instructions. So they restarted and carried on with the filling up the tower. They left an auto level valve closed, which is shown here with the little blue line encircled. Of course, the auto level valve was closed. it meant product was not exiting the tower. So they're filling it, but there's no balancing going on. So the tower continued to fill higher and higher. Remember, the level gauge stopped at 9 foot. A bit later in the day sweeper left, a family emergency. The procedure was that the supervisor should be replaced. He was not. No one was sent to replace him. So this left one day supervisor. You can see it's now 10 to 11. So it's a long process. You need to be aware what's happened before. You need to know what you should be doing now and next. So you now got one operator. This one operator was operating 3 units. And you can see with the snippet of the screens here, the complex units on a complex refinery. So now one operating 3 units. Responsible for startup, that required close attention. That operator, 30th day of work, early start, a poor handover. No. There had been a second board operator, but that operator in as a financial saving, efficiency saving. So clearly, one operator in a very difficult position, exhausted, tired, overloaded, with inadequate information, inadequate handover. You might say recipe of failure. Continue filling the tower. Investigation found it been filled at this point to 98 feet. Standard procedure was 6 feet. So level is now 15 times the normal level. The gauge said 8.5 foot. The gauge said the level was falling, misreading. Also, obviously there's the mimics of this process, but on no single screen was the flow in and out of the tower shown on one screen, which might help you realize there's more going in than coming out. You had to look at different screens, the switch between different screens to see the inflow and outflow. And no indication of total volume of liquid in the tower either. So again, the operator unaware of the level, unaware of the flow, unaware of the position, because of the poor interface design and the poor instrumentation. Notwithstanding that, the operator did become concerned about the levels, turn off the furnaces, heat the raffinate, open the pressure relief valve, and started to try to reduce the level at the bottom of the tower, as shown here by the red pipe at the bottom. Tried to direct some of the contents to storage tanks. Unfortunately, the outflow went through a heat exchanger, exchanged heat with the incoming liquid. So as you can see on the top pipe here, the temperature of the incoming liquid was raised to 141 Fahrenheit. So you now got hot liquid going into a tower, which was already filled full of hot liquid, which obviously led to the content expanding and rising yet further. And ultimately, the liquid rose to the top and overflowed through the top pipe, ran down the pipe you can see in grey down to the bottom and base of the tower, where it went through and some pressure relief valves lifted as intended, as designed. The liquid went through the pressure relief valves to a blowdown drum, large blowdown drum. Again, the high level alarm in the drum did not activate. So again, the operator would have no indication of the level, or indeed the liquid being in the flow down drum. The operator was unaware of what was happening. The blow down drum continued to be filled, and ultimately, like a fountain, the hot flammable liquid came from the top, fell to the ground, started to evaporate to form a flammable vapor cloud, which spread and spread and spread. There's a truck nearby. As it was overcome by the vapor cloud, the driver in the truck couldn't turn the engine off. The truck raced. The workers in the truck evacuated, but the truck engine ignited the cloud. And you can see the animation of the explosion in the bottom right. The explosion swept through the portable cabins inhabited by the hundreds of workers, destroying the cabins, killing 15, injuring 180. Effectively, everybody is either killed or injured in those cabins. It's 90 seconds between the liquid being spouted from the top to ignition. The opportunity to evacuate, to escape, was not there. And we say this is why we should care about human performance. Those issues were foreseeable, they were substantial, and should not have occurred. Look at the contributory factors. No communication with the trader workers who could have been relocated that day. The level gauge, nothing above 9 foot in a tower that was 100 feet or so. There's no mimic in the in and outflow to the tower. It's practice to exceed the normal startup level. Should be 6 feet, they naturally went above that, despite there being a gauge only to 9 foot. One operator with 3 units, 30 days working, whole handover, 40 high level alarms, a recipe for failure. And this is in a way why we say error was not the cause of this accident. It was these conditions which led to the error. So human performance is about foreseeing these conditions, preempting these conditions and factors, so as to prevent and mitigate these major accidents, prevent that major loss of life, damage and destruction. And we say that's why we should care about human performance. Key principles, key concepts. First key concept is, it is human to err. To err is human. Even the most experienced, expert people can commit error. When you think about airline accidents, pilots are highly qualified, highly experienced, yet they make mistakes. These operators, highly experienced, highly trained, yet they made mistakes. And you're particularly likely to make a mistake if it's 6 in the morning, you've lost some of your sleep, you've been working for 30 days, and you're confusing instrumentation. So it is human to err. So what we need to do is foresee where error may occur, understand why the error may occur, and take actions to prevent it. Blame, and often with these major accidents, people like to try to discover who was at fault, point the finger at them. And Todd Conklin, a safety expert, I think it's a great quote. You can blame and punish, or you can learn and improve, but you cannot do both. We say that blame, fault finding, it blinds you and deafens you to what actually caused that error. All the issues with training and interface design, staffing levels, it blinds you to these factors. And what we really need to do is identify these factors, resolve the problems, if you wish to prevent other people committing similar mistakes in other operations. So a key principle is not to attribute blame, not to have fault finding against individuals. is to understand that you all err, and what we need to do is identify the factors that contribute to those errors, understand those factors, which are really the responsibility of the organization, not the individual. So building upon that, and with this picture here, really error. When you look at a tree, you can see its branches, you see its leaves. That's visible. That's what's visible to you. But underneath the tree, in the ground, you've got the roots, maybe the root causes of those errors, which we call performance influencing factors, which is a key human factors concept. The training, the procedure, the workload, these are the factors that influence the performance of people, mainly the errors that you can see. So human performance, we need to identify these factors, understand these factors. PIFs, so a little abbreviation. And there are categories and checklists of PIFs, and the United Kingdom's Health and Safety Executive offer up 3 categories of PIFs: individual, job, organisation. At the individual level, you've got their physical capacity, their mental capacity, their fatigue, their stress, their morale, their workload, their motivation, individual factors, which are still the product of the organization's training, selection, its leadership, have incentivized people. These are still the result of the organization's work. We've got organizational factors, the staffing levels, peer pressure, culture, clarity of roles, responsibilities, the job, how complex and difficult are the tasks? Are they routine or unusual and infrequent? How much time do you have to perform the tasks? How good is the interface, the instructions? Now, there are many other checklists of PIFs, but here's an authoritative, well-recognized one, which when you're looking at a task and you perhaps auditing and evaluating a task, you use this as a checklist to guide your assessment of that task. So another key concept. Next question, what is human performance? And on the right here, you've actually got an image, and it says human factors. And many of you will be familiar with the term human factors. You also got the term ergonomics. In a way, the terms human performance, human factors, ergonomics are really interchangeable. Very, very similar words, very interchangeable, really. Human performance in practice often has a greater focus on operation and maintenance. Sometimes ergonomics has a focus on equipment design. So maybe a different focus, but really the terms are interchangeable. And in all cases, this is a multidisciplinary area. When you're thinking about physical factors, you've got physiology, you've got cognitive factors, you've got psychology, and culture is a psychological thing. Often people in this area come from an engineering background. You get interface design, anthropometrics for biomechanics, fitting equipment and workplaces to the dimensions of people. So you have element of science, we have methods, task analysis, error analysis, link analysis, timeline analysis, many methods. We've got principles, such as to be user-centered in the design process. We've got concepts such as no blame being a concept. So a bit like engineering, a mix of science, methods, and good judgment. There is an immense amount of human factors and human performance, good practice guidance out there. Got a few examples. The Centre for Chemical Process Safety recently issued the book on the top left. UK Health and Safety Executive issued many guides. The Energy Institute has a wealth of guidance on human performance. And other organisations like the ISO, EEN, UA offer a plethora of guidance. And the scope of human performance. You've got analytic methods, and common ones are walkthrough, talk-throughs, task improvement process, design, user-centered design. You've got design standards, got anthropometric guidance. You've got good practice on competence and non-technical skills, communication protocols, methods and guidance on fatigue and staffing levels, culture, teamwork. So this makes the point that human performance covers a very wide range of topics and issues, which leads to the question, who manages human performance? And you think about the breadth of human performance, it touches upon many aspects. At the top, you've got engineers, designing equipment, interfaces, control rooms. You've got operations and maintenance people, looking at training, procedures, staffing levels, shift systems. Safety specialists who should incorporate human factors into HAZOP and HAZAN. Human resources people should be involved in recruitment, senior management, and leadership. So really, human performance is managed by this very wide range of roles in energy companies. The key challenge here is that, taking some data from America, the American Human Factors Ergonomic Society has about 3,500 members. The American ICME, 60,000 members. The American Institute of Mining, Metallurgical and Petroleum Engineers, 200,000 members. You've got 700 engineers for every one human factor specialist there in America. And the human factor specialists don't all work in the energy sector. They often work in consumer products, aviation, transport, defense. So the ratio of engineers in the energy sector to human factors people is probably greater than 700 to 1. So how can you resource and implement human performance in practice when you've got such a massive ratio? So there's a number of common approaches. At the top there, you can see obvious one, the use of consultants, people like me. This is done especially for major projects when a company's got developing a new facility, a new plant. You may bring in consultants for that short period of time to support a major project, or to do specialist work in the world of human factors. That's a very common approach. Of course, there's still only one human factors specialist for every 700 engineers. Consultants can be in short supply and expensive. So some companies on the left, they recruit human factors specialists in-house. And I know particularly in the nuclear sector, in the UK, every large nuclear company has a team of 10 or 20 human factors specialists, provide the support to engineering, to operations, to safety assessment. And that can be very successful, can be very effective because you've got that in-house capability. And some energy companies also recruit human factors specialists and teams. But again, there's not many human factors specialists. It can be difficult and challenging to employ them. So at the bottom there, some companies employ 1 or 2 human factors specialists to be champions, to be an intelligent customer, leading up human factors work, but using other people to deliver it. But on the right there, remember, you still got all these engineers, operations, maintenance managers and supervisors, safety specialists, who on a day-to-day basis will be making decisions that influence human performance. And there's many of them. So clearly an option is to upskill the bulk of people in these energy organizations, the engineers, the operations, maintenance, safety people, upskill them in human performance. And this leads on to the idea of training and different levels of training. Training the engineers, training the operations and management and supervisors, training the safety specialists. And you can think of it at a number of different levels. Introductory level. And really our advice is that all these roles should have an introductory level training to human performance. Some hours of understanding What is human performance? Why is it important? What are the key topics and methods? How does it apply to the decisions made by operations, maintenance, safety, and engineering? Everyone should have that introductory level training. But really, there are some core methods, walkthrough, talk-throughs, for example, that are quite simple. Which again, all these roles, if you're producing procedures and training, you should be doing a walkthrough, talk-through. If you're looking at shift systems, you should have an awareness of fatigue. If you're looking at staffing levels, you understand the issues of workload. So you should have some core level of knowledge and awareness and be able to apply some of the simpler methods if you're developing training procedures, any sort of design activity. But if you are an engineer or a safety specialist, really suggesting you need to level up from that. To design interface, really need to understand the principles of good interface design and some of the methods of interface design. So an intermediate level. And really to lead this up, to coordinate this, the advice is that every company really should have a human factor champion or specialist in their organization to lead, coordinate, develop standards and policy in this area, provide that specialist support. And this is where the learning pathway comes in. It's designed for non-specialists, people without specialist expertise in human performance. You may be an expert engineer, expert in operations, a safety specialist, but may have no background in human factors or human performance. And that is what the Human Performance Learning Pathway is designed for, is to support developing the competence of engineers and operators, safety specialists in human performance. So it helps organizations to implement human performance without being completely reliant upon consultants and the rare breed of human performance specialists. Thank you very much. I will now hand over back to Alex, who will speak for a few minutes before we take questions. Thank you.
Thank you, Michael. Hi, everyone. Sorry, let me just share my screen. So now that you've all heard about what human performance is and why it's important, I'll introduce myself. I'm Alex Pascalis. I'm a technical officer at the Energy Institute, and I take care of one of our training courses, the Human Performance Pathway. So the Human Performance Pathway is a self-paced, self-taught online training course to be done while at work in your own time. The goal of the pathway is for you to learn how to manage human performance by actually doing it. Anyone who doesn't have an academic background in human factors can do this pathway, and they can learn how they can apply relevant human performance tools and techniques in their organization. So there are 4 levels in total, starting with the introductory module. As the name suggests, it's an introduction to human performance. This level is really for anyone and everyone. And once you complete it, you can move on to level 1, which is perfect for managers, supervisors, senior leaders, engineers, and anyone who has a safety management role. Then you have level 2, which is really for safety and operations managers, engineers, and anyone who has a role in the topics that are covered in the pathway. The final level, level 3, is for anyone who's a human factors champion or specialist. The human performance pathway is designed so that if you complete every level, you should have the knowledge and the competency required to apply to become a technical member of the Chartered Institute of Ergonomics and Human Factors. So to go into more detail, the introductory module is suitable for everyone in your organizations and will give you an awareness of what human performance actually means, what things can affect human performance, and how human performance can be managed through design, people, and processes. It can be completed in around 1 to 2 hours and is a fully interactive e-learn in which you'll learn about human performance by exploring 2 incidents. It covers a wide range of different topics, and it will teach you how these topics can contribute to incidents, as well as help you to understand and avoid those incidents. I'm just going to show you quickly what the introductory module actually looks like while you're navigating it. So if I just come out of here. Yeah, so this is the introductory module. You've got a bit of text here. You have some tabs where obviously the main tab is it has all of the different topics, all of the different lessons. You can specify it by topic or specify by one of the 2 scenarios. So if I just click on safety culture as an example, one of the good things about this introductory module is you have these animated. Yeah, so I won't play it because there's audio, but you have these animated videos, which are very helpful, and you've got transcripts as well for them. You've also got these different tabs. So, for example, this one, you can click on one of these different leaders, and they'll tell you the ways that they like to build a safety culture. So you've got Louise, got some quotes from him. Then you have a summary, you have some points of reflection, some points of what you can do next. And then you've got some links to some reading you can do. Okay. So the introductory module is available for free, but you can also purchase it for £20. The free version is really for anyone who just plans on doing the introductory module and doesn't plan on doing the following levels. But if you're anyone else, or for example, if you're a company that wants to sign up a lot of employees to complete the introductory module, then the paid version allows you to track progress. Other than that, though, the actual content is the same for both versions. So to reiterate, level 1 is great for anyone with a role in managing safety and will provide you with a deeper understanding of human performance and actually allow you to apply this knowledge in your workplace. While working through this level, you'll actually go and speak to other people in different roles and you'll hear their insights. So for example, you might go to the control room of your workplace, if you've got one. You might speak to the people operating it, fill out a checklist with them, and identify potential areas for improvement. There are 9 different modules, each including some pre-reading, desktop and practical exercises, and an end of module quiz. To receive the end of course certificate for level 1, you need to pass the end of module quiz and the activity report for each of the 9 modules. The activity report is simply just for each module. When you go and do these activities, like reviewing equipment design, you basically just write up your findings and you submit that report. And it should take around 1 day to complete each module. So for level 2, level 2 is for those who manage human factors or have a role in any of the module subjects. This level is similar to the first. However, rather than doing all 9 modules, you choose 5 that you like to begin specializing in, and you learn about these topics in more depth. You'll be reviewing your company's policies and processes for managing human performance issues against good practice, including assessing equipment and tasks, talking to colleagues about their work, and more. When you sign up to level 2, you'll be assigned a tutor who will be available to guide you and answer your questions. Michael Wright, who you just heard from, is actually our first Human Performance Pathway tutor, so you could end up with him. To receive your end of course certificate for level 2, you'll need to pass the activity report and quiz for each of the 5 modules that you chose. And each module takes around 1 week of work. Level 3 is for anyone expected to be a human factors manager or champion, subject matter lead, or a specialist. For this level, you choose 2 modules to continue specializing in, and just like level 2, you'll have a tutor as well. To get the final end of course certificate, you only need to pass the activity report for the 2 modules that you choose. There are no end of module quizzes for level 3. And the estimate is that it takes approximately 1 to 3 weeks to complete each module. So that's the Human Performance Pathway. Thank you for listening to myself and Michael. If anyone has any questions, yeah, now is the time. So I'll just quickly say that there's you should all be sent this PowerPoints at the end of this, but the link to the pathway is here. Yeah, so I'll just stop sharing my screen and I'll bring Michael back in for any questions.
Perfect. Thank you, Alex, for that run through of our human performance pathway. And thank you, Michael, for running through an introduction to human performance. So yeah, as Alex said, we will open the floor to questions. I'll quickly just add that we will be sending around an email with links to each course page, how you can book on, and also we will share the recording of today and the slideshows from today. But yeah, thank you everyone for joining. But yeah, we'll open the floor to any questions. Feel free to use the chat box or just unmute yourself or raise your hand. That would be great.
Perhaps if I pose a question to our audience, if I might ask anyone on the call here, and whether their company already has human factors specialists employed. Alternatively, have you? So Hannah McIntosh saying you have a small team. If I might ask, how was the experience of the effectiveness of employing your own specialists so far? So Hannah's saying it allows them to access experience faster if you have employed some people in-house. But Hamish, you say you currently don't have in-house specialists. When you say looking to expand services, is that by recruiting human factor experts or by training up your engineers and operations people?
We have a hand up from Stuart.
Okay. Hey, well, just saying, Hamish is saying that they're looking to upskill. I think he's volunteering himself. But also Carrie Lawson looking to introduce. How do you introduce into your company? I think our really advice comes a number of respects. How do you introduce human performance into a company? I would strongly recommend the free e-learn that Alex showed you. Is a few hours long, which is actually very good. The scope is very good. It's a very high quality, interactive, animated package. And I would actually say that if your managers and engineers viewed that, it gives them very good awareness of what is human performance, what is the scope. And from that, you can then start to have better understanding of how might you go about upskilling or bringing in. What many companies do, if they're large enough, is they do employ a human factor specialist or champion. And if they don't have human factor specialists, they appoint one to be a champion and then try to upskill that individual. So often having one person who's the champion for human factors, leading up, coordinating this, it's a common starting point. But really, it's hard to get over the fact that you need to train up and develop your engineers, your operations specialists and safety specialists one way or another. And Marjo is saying, should you integrate human factors into current processes? And we would say absolutely yes. It's often at a company that will have a human factors policy and human factors standard. And as part of that, though, you would look at all aspects of your process safety management arrangements, your approach to safety assessment, and you look at how do you integrate human factors into safety assessment, or how do you integrate human factors into major projects. So all your safety policies and procedures, your major engineering policies and procedures, you put human factors into each or of them. Given the wide scope of human performance, really all your management policies and processes, there'd be an aspect of human factors to be, and human performance to be dropped into it, which is a common approach to integrating into your policies and procedures. But obviously, just because it's on paper doesn't mean anything happens, which takes you back to developing the competence of your people to implement those methods and policies and procedures. Shall we let Stuart with his hand up come in?
Hi there. So a question for Michael. The example that you used, Michael, was of Texas City, which is obviously a major accident in the petrochemical industry. I'm not sure what other companies are on the line today, but is human performance also of a concern in slightly different sectors, such as the offshore wind sector, where perhaps they have very different hazards? Perhaps, I'm sure they do have process safety hazards, as you could think of them, but a lot more personal safety hazards as well. So is human factors just for the major accidents, or is it much broader than that?
Yeah, well, I have done work, human factors, human performance work for the offshore wind industry, but also onshore turbines and hydro. Now, firstly, with offshore and onshore wind, you've got to maintain the turbines. You've got accessibility issues. You've got heavy lift equipment to be manhandled. You've got working at height. If it's offshore, you've got to get from the shore to the turbine. So you say you've got shipping issues, transfers from the ship to the turbine, which may not be always major accident hazards, but they are safety critical activities where workers can die. But also, if you don't maintain the turbines correctly, they can fail. And onshore renewables, some key human factor issues that I've been personally involved with is the potential for human error in the maintenance of turbines, maintenance of the dams and infrastructure. And all of these systems have control rooms where you've got operators having to often perform high workloads at speed, managing the energy network. And with energy management, it may not be a major accident hazard risk, but in terms of commercial performance and management of the energy network, powering up, powering down, you've got sometimes a minute to correctly balance the system. So you've got a person operating the energy network in seconds. You've got to get that correct. So it has enormous commercial ramifications. Thank you.
And we have hand up from Chris.
Oh, hi there. This is Chris from the Mistras Group. It's actually to tag on to what Stuart was saying, because the field we work in is asset integrity and inspection services. So we're starting off on the human factors journey. My colleague Jamie's on here as well. And, we're, and thanks to Alexandros taking us through the process, because we're going to go all the way through to the top level. But, it was a similar sort of line along Stuart's question is, although we are not process systems, we are involved with the inspection of processes, from everything from bridges, refineries, tank inspections. We work on ships, you name it. We work on it to, if it holds anything or if it's under any kind of pressure using radioactive isotopes, we have to inspect it, and obviously various other techniques. But it's bring in human factors into that kind of work when we're working within other processes. So it's how do we dovetail into, say, for example, we work with BP on a refinery, and using our human factors dovetail into somebody else's human factors. Is there a method or a way of doing that would be successful?
If I might, I'll give a partial response. I think in the energy sector, most of these large organisations like BP, Shell, Exxon are quite mature in their approach to human performance, and they often have a range of policies and procedures and practices, which once you've identified and understood them, you can basically mirror their policies and procedures. I think if you're involved in inspection and testing of plant and process, there will be some core human factor methods which BP would apply to themselves, would be equally applicable to yourselves. So the task improvement process would be one example. You're talking through an activity, identify potential for error, and then look at the PIFs and how can you improve the support offered to that task. Equally applicable to inspection, maintenance, operations. It's generically applicable method, and that is one which NEFRAC BP developed the task improvement process. There's a free module on that too. So adopting the same sort of methods, I think, would be an obvious step in meeting and mirroring the good standards which companies like that can now often achieve.
Okay, great. Thank you for that.
Any more questions?
I think there's a question in the chat. How do you see the implementation now the topic is introduced as separate, so bringing in human factor specialists, etc., but isn't it more important to integrate the approach in the current processes?
Yes, I do think that in practice that having some specialists and champions for human factors provides that a coherent view and leadership. At the same time, in practice, if your engineers and safety specialists, operating specialists have some understanding of human factors, they can for themselves judge what are the issues in their jobs, what are the key methods and concepts to apply. So even the introductory level, the level 1 part of the course allows the wider management and engineers in a way to understand where human factors and human performance affects their work, and even if they can't apply the methods themselves, they can draw in other people in. So I think it's a balance of having champions, upskilling people, and having a body of policies and procedures. One of those procedures which companies often have is a human factors integration procedure. Whenever there's a major engineering project, you have to look at all the touch points of human performance in a major engineering project and have a plan for its integration. And that integration may actually be delivered by the engineers, but it's guided by a plan. So it is a balance of engineers doing it for themselves with some leadership and support. Thank you.
It looks like there's no more questions, but if you feel like you have a question after the webinar's finished and you didn't get a chance to ask it, I'm just going to drop our training team email in the chat box. So feel free to drop us a question in there, or if you have any questions regarding the webinar, feel free to just let us know and we'll be happy to answer those for you. Once again, thank you, Michael, for presenting today, and thank you, Alexandros, as well. Thank you everyone for joining today. If you have any questions, again, please do let us know, and I will be sending around an email with the webinar recording and any information you will need to join our courses and join each level of the pathway. So yeah, if you have any questions on the back of that as well, feel free to let us know. Other than that, thank you everyone for joining, and hope you all have a lovely day.
Thank you very much. Thank you.
Thank you.
Thank you, everyone.